Hi there, guys. This is Maitri Patel, and I'm back with another assignment video. So today, I'm gonna explain assignment 3 of applied machine learning. So let's not waste any time and let's get started. So in this, the idea of this current assignment is to intensify what we have learned about convolution neural networks. So in this first thing, it's is image convolution, in that we have to import libraries and necessary packages like NumPy and other things to make our thing work. So in this we import the image. I have put there's this link from where we are getting the image for this assignment. So when we have to visualize the content of the response, so when we print the content, it's a very long content for the image. So it's like x00 x01. It's all in computer language, but it's a long content, but it's also the response for to print the content of the image. And further on, after that, we have to transfer the image into 3D array using NumPy. As you can see, we have done it over here, and this is all pre-coded. I thought explain it. So after that, we have to plot the resulting image from the array that we chose, and after that we have to print some arranged and compare values with color channel 0 and 1. And as you can see, it says both of them are false over here, as you can see that. Moving on, after that, it says you have to save the color channel for 0 into the input image array variable and print it. So this is already written over there, how we can do and change the color for the car. After that, we have to visualize the value inside the image for resulting array. So it's between 0 to 255, so it would just be between that, not more than that. After that, it says convolution with 2D kernels, and this it says create a padded array by adding 2 rows and 2 columns, and it's written over there. We have done the coding as per that. Also we have to create the kernel. As you can see, we have created that too. And after then we have to plot the resulting array. So kernel to array value over here, as you can see. And after that, we have to apply the kernel to the array values, as you can see. And this is the resulting array that we can see. As you have written it over here, gray. So as you can see, we got the image of a gray car, which was different than the others up over here. This we got over here red. This. So after writing that, the resulting array, we writing over here gray. We got a gray car. So it's already pre-coded. So the process is to simplify that image and define a kernel for 2D image. So after that, moving on to standard convolution. So it says define a function to squash out the values between 0 to 255 range. So this function is the resulting array values, in which it can be negative or greater than 255. As you can see, we have done that. And after that, we have defined a function to apply a convolution 2D kernel to an image, as you can see over here. After that, line detection. So in this, as you can see, we have to create a kernel to detect horizontal lines. So over here, as you can see, I put 2 to 2 and horizontal line. So after that, we have to plot the resulting image as well. So for the question 1A, it's like now is the thing that I've coded. It says based on the kernels represented on the above image, create a kernel to detect 45-degree line using convolution applying to the car's image and plot the result. So for that, I put the kernel name as kernel1, as you can see, and put it in the numpy array, and I also put 45 degrees line over here because it's been asked over here. So yeah, so it would detect the 45-degree line over here. And but for like the second one, it says we have to detect 135-degree line, so using convolution. So we just on this we put the name kernel2, but for from the upper one we just like changed 45 to like 135 over here and run the program. After that, moving on to edge detection, it says apply the following kernels to your image and plot the output. So the second image is for like is for basically for edge kernel. So basically for sharpening the edge. So I wrote the code as per the edge kernel transformation over here. As you can see, the first one over here, and then the second one, it's in this one. After like doing the code, the image would appear brighter than in the first one, as you can see over here. But after doing like the whole code in the second one, in the third one, we can see all the details of the Lamborghini car in that image. As it like it's like a detailed image of the car that we worked on, like the image that was represented. And the upper ones, as you can see over here, yeah, it's a detailed image of that over here, as you can see. Yeah, after that, moving on, the import part B, importing libraries. So in this also we have to import all the libraries as per it's delivered in the assignment. After that, we loaded the data set, as you can see over here, and then created a data set like hot and colored target values, like one hot anchor target value and converted also from integers to floats, and also we were normalizing it to this all and between range of 0 to 1, and this all are mandatory to put in like neural network. After that, we have to build a neural network model as per the dataset up. So I have built that. So as you can see, I have used the convolution layer, max pooling layer, flatten layer, the ReLU revolution, and the softmax one over here, as you can see. After that, like I compiled the models, and in that the optimizers item, like the categorical cross entrophies and the matrix accuracy. So after that, like we have to display a summary of the model. So basically this is the summary of the 5 layers that we have: the convolution 2D layer, the max pooling layer, the flattened one, the ReLU activation one, and the soft max activation one over here. This board are different. And after getting those 5 layers, we move on to custom callback class for login. So for that, we have to like create a custom callback class to be called during the training. Okay, and then initiate the custom callback. So for like the training network, we have to like train the network with train images and train labels. So in this we have like epoch 50 and like the validation data and callbacks for it. So as you can see, we have like 5 layers of accuracy for the training over here. As you can see, we have 5 layers of accuracy for the training data set. So in this, as after running all the 50 reports, as you can see, we got a pretty good accuracy, which for training data is 0.94. But for the validation one, as you can see, the validation accuracy, it got stopped. So it's not much. It's like around 60, 60, 75. So like it's around like, as you can see, it's over here 64, 65, 65, 65, 0.65. So it's after a certain point it got constant. From first, like from epoch 0 to like epoch 10, it was like increasing, but after epoch 10 it was all constant. So to see that, we can also see the result in this graph. Like the training accuracy went high up, like around 0.94, which was our result and which was pretty good. But the validation accuracy was around 0. Was increasing around like till epoch 10, but after 10 it remained constant, and it's not that good, but it's okay. So after that, like, okay, the question answers. So in this, like, it asks that did the network presented signs of overfitting? If so, in which reports? So as I told you up, like it did present signs of overfitting, as you can see in that epoch, but it did after epoch 10. Till epoch 10 it was going good, it was going smooth, but after epoch 10 it got constant, and yeah, it presented the signs of overfitting. So, like, write down how many layers this model has and identify their types. So, in this, as I told you up, like, we have like 5 layers for this. So, first one is 3D convolution layer, second one is max pooling layer, third one is flattening layer, then the layer, which is the ReLU activation function, and the second dense layer, which is the softmax activation function. So after that, there's this question that says that briefly explain what is the purpose of each of those layers. So in this, like the 2D convolutional layer, so this layer is used frequently. Its process is sliding the filter over input. It is a way of detecting patterns or features in input signal. Second is max pooling layer. In this, the purpose of it is to downsample the output of a convolution layer by retaining the most silent features while reducing the dimensionality of the data. Whereas like in the third flattening layer, and the purpose of it is to transfer the output of a convolution or a pooling layer into a 1D vector that can be used as input to fully connected layer. The fourth one is ReLU activation function for the dense layer, and in that the purpose of it is to introduce nonlinearity to the output of a neuron, enabling the network to learn more complex and expressive representations of the input data. And lastly, the softmax activation function of dense layer. In this, the purpose of it was basically to convert the output of the final layer into a probability distribution over a set of classes. So after that, the question goes, add one or more convolution layers to your model and run it again. So for that, as you can see over here, I have added one more convolution layer to the model, and then we run all the 50 ports again, and now as you can see it got better. So in first over here, as you can see, it till 10 it was like going smooth, and after that it was constant enough, like 65 and stuff. But after adding one more convolution later, um, as you can see, it's differing. Like it started from 52 and then 66, 69, it went till 70, and after that it became constant, so around 70, 69. So that's a good change. First it was still 64 something, but this time it went till 70, till 24. So 20th report. So the training accuracy, as always, it was increasing in this one too. It was pretty good, as you can see. It's 95 in this one. So that's very good. But the validation accuracy that we have was increasing till approach like 20. It was going with a good flow, and then it went constant. But after adding that convolution layer, it's good. Like it was first 0.64, now it went till 0.70. So the results are pretty good after adding a convolution layer. So in this, it says compare the result and describe what are the differences between them. So as I said earlier, it says comparing both of the model, we can clearly see the model with two conventional layers, which can give us validation accuracy of almost 70%. That's very good. While the one before that, which we tried with just one convolution layer, it just gave us 60. So the second model, on my perspective, is way better than the first model. After that, over here, as you can see, I had to add a dropout layer to the model and run it and compare the result with the previous one. So over here I added the dropout layer, as you can see, to see the results, what we get through that. So, and after that, like, I also compiled the new model that we got from the dropout layer, and then run the post, and it's pretty good after that too. Like everything went very good, but it's still like the same, not that much, okay. But the dropout layer did make some differences, as you can see over here. And after that, like after like to result the plotting, like training accuracy as always was very on point, but the validation accuracy also went well due to like the dropout layer that we added. So the first one we added like one convolution layer, and it was good, not that, but not that much, but it was good. And the second one we added two convolution layers, and it gave us very good result. The third one, it said us to add a dropout layer, so we added that too over here. And because of that dropout layer, our results had increased, and it went up over here. And after that it went like constant. So it's pretty good. Like it was constantly like growing up, not in one particular position or coming down. It was constantly growing up after adding a dropout layer. So now the question over here, it says explain with your own words what is the purpose of a dropout layer and how it works. So for my thing, I think that the purpose of a dropout layer in a neural network is to prevent overfitting and improve the generalization performance of the network by randomly dropping out and setting to zero some of the neurons during training. Overfitting also occurs when a neural network becomes too specialized to the training data and is unable to generalize well to new unseen data. So, for that, the dropout is a regularization technique that helps to address these problems by reducing the codependence between the neurons and encouraging the network to learn more robust and generalizable features. And After that, over here, as you can see, it says make any other modification in the hyperparameters to improve the model's accuracy and compare the final result with the previous ones. So I changed over here the dropout thing, and we added like two relu activation function and one softmax, as it's said to like change stuff. So I changed it to like two convolution, added one dropout, and also added two relu activation function, and then compiled the result. And after getting the imports value, it went very well. After doing that, like accuracy started from validation accuracy started from 50, but eventually it went till 76, and that's pretty good, and it was growing constantly. It didn't remain at one place or drop down after the changes that I made. So after that, you can see the results over here. As you can see, the training accuracy, and then after the validation accuracy, that went till 0.7576 and was constantly increases, as you can see in this graph showed over here. So yeah, that's all for this assignment 3. Hope you enjoyed watching it and learned something from it. And yeah, thank you so much for listening to me, and hope you have a great day ahead. Thank you. Meet you next time with next assignment. Bye.